All right, so this is going to go through the idea of ions. And so ions is something new that we're going to talk about, and ions deal with atoms and just kind of how they can change. So the main thing to understand is that ions are atoms that have either a positive or a negative charge. And so they're going to have a positive or negative charge because atoms are going to gain or lose electrons, basically in order to fill their outer shell. If we think about the periodic table, this family over here is the noble gases, right? And the noble gases are really special because they have full outer shells. Essentially, every element has 8 in the outer shell besides helium, which helium only has 2, but still, because that first shell only holds 2, all of them are full. So atoms want to become like the noble gases, so they're going to gain or lose electrons in order to do that. So what that's going to look like is, let's imagine we have beryllium. So beryllium, if we draw the Bohr model for beryllium, beryllium has 2 shells, and it has 2 electrons in the first shell and 2 electrons in the outer shell. And so this is beryllium. We would call it 4, 2. Its mass is 4, its atomic number is 2 because it has 2 protons. But this outer shell is not full, so it's not really that happy. So what it's going to do, it has an option. It can either gain 6 more electrons to fill its outer shell, or it can lose 2. And so it's going to do the easier of the 2 options, and it's going to lose, it's going to lose 2 electrons, and in doing so, then we would draw beryllium to look something like this, Be. And now, it only has that inner shell because these 2 extra electrons just kind of go away, and we'll talk about where they go another time. But now this is a full outer shell. And so we would actually write this beryllium 4, 2, still has a mass of 4, still has an atomic number of 2, but now it is 2 positive. It has a positive charge now, 2 positive. Right? Another example, fluorine. Fluorine starts with an atomic number, fluorine, not beryllium. So fluorine starts with an atomic number of 9. It has an atomic mass of 19. And so it's going to have 2 shells, because again, it's right here. And there's going to be 2 in the first, and now 7, 2, 3, 4, 5, 6, 7 in the second shell. It's still not full. It needs to have 8 in that outer shell. So it has one of 2 options. It can either lose 7 or it can gain 1. It's going to do the easier of those 2 options. It's going to gain 1 electron. That electron is going to come in from somewhere. We don't need to worry about where yet, but we will talk about that. And basically what that's going to do is that's going to fill its outer shell. Now if I looked at fluorine, it would have 2 in the first shell and 1, 2, 3, 4, 5, 6, 7, 8 in the second shell. And essentially what that does is that now fills its outer shell. So it is now full. We would still write it fluorine 9, 19, and now it is a 1 minus. So it has 1 negative charge. So this idea of charges, there are 2 types of charged atoms. Obviously, it can be either positive or a negative. A negative charged atom is considered an anion. So this is an atom that has more electrons than normal. So we already did fluorine as one example. We'll do another example. So another example would be oxygen. Oxygen has an atomic number of 8, an atomic mass of 16. And so if we do the Bohr model for oxygen, what we're going to get is, there's O, here's my first shell, here's my second shell. We'll get 2 in the first shell, and 1, 2, 3, 4, 5, 6. right? Oxygen is basically right here on my periodic table. So it has two options. It can go 1, 2 to get to neon. It can gain 2 electrons to get to 10, or it can go 1, 2, 3, 4, 5, 6, right, to get back to helium. So it can gain 2 or it can lose 6. It's going to do the easier of the two. So this is now going to gain 2 electrons. And in doing so, again, we don't need to worry about where those 2 electrons are going to come from, but 2 electrons are going to come from somewhere else. And now we're going to get oxygen, with 2 shells, 2 in the first, and 8 in the second. 1, 2, 3, 4, 5, 6, 7, 8. And so this now becomes oxygen. 8, 16, and now it has 8 protons, but now it has 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So now it is a 2 minus because it has 2 more electrons than it has protons. Again, the adding or the gaining of electrons makes it a negative charge. All right, and what we'll see is that almost all nonmetals are ones that will gain electrons. So nonmetals are sit over here. It's easier for them to move this way on the periodic table in terms of gaining electrons than it would be to move the other way. And so anions are typically going to be nonmetals. The other form of an ion is something that's called a cation. Cation is a positive charge, and I remember cat as positive because there's a T in it, and T obviously makes a plus sign. This is one that has less electrons than normal. So if we look at that, if it has less electrons, now it's going to have more protons than it will electrons, which would give it a positive charge. And so an example of that, we've already done a beryllium as an example of that. Another one would be sodium. So let's do sodium. Right? Sodium has an atomic number of 11, has an atomic mass of 23. Right? So if we do the Bohr model for sodium, it has 3 shells, right? Because it's in my third row. I even almost made that mistake because it's right here, right? Here's sodium. Okay, so I'm going to fill in its total number of electrons. 2 in the first, 8 in the second, and now 1 in the third. And that gives me a total of 11. Now, sodium has one of two choices. It can either gain 7 more to fill that outer shell, because that second shell can hold 8, or it can lose 1. And obviously the easier of the two is it's going to lose 1 electron. So this extra electron right here is basically going to go away. Right? And what we'll see then is sodium now has a full second shell. And it loses that third shell because there's no electrons in it. And so sodium has 1, 2 in the first. 1, 2, 3, 4, 5, 6. Whoopsie. How'd that happen? 1, 2, 3, 4, 5, 6, 7, 8. And now it's a full shell, which makes it happy. All right? And now what we would do is we draw sodium. And it has an atomic number of 11 protons. It has 23 as its mass. And now it has only 10 electrons. So because it has 10 electrons, it has a 1 minus charge. Oh, I'm sorry, 1 plus. 1 plus charge because it has 11 protons, 10 electrons, which leaves it as a positive charge. And what we'll see is that almost all of cations are metals. So metals are typically the things that are going to form the cations. And so those elements are right here. And so what we'll see is we'll see a pattern. Basically, anything in the first column has 1 more or 1 valence electron, so it's going to form a 1 positive charge. These have 2 valence electrons, 2 positive. 3 valence electrons, 3 positive. All right. So just a quick introduction to ions and how they will either gain or lose electrons.